Okay guys, so today I'm going to talk to you about reclassifying data using a tool called Rescale by function. I'm also going to show you the Euclidean distance tool. And then we'll talk about some of the options inside Rescale by function and finally end up with some Raster Calculator work. The whole idea is we've been talking about reclassifying data, classifying data, looking at our data and how do we find the breaks that we want to use, and purposes of reclassifying on a scale of 1 to 10 for things like site suitability analysis. So we're going to actually do a quick demo here, and I'm going to fast forward through some of this analysis or pause the video just to try and get through this somewhat quickly. But hopefully by watching this you learn a little bit about Rescale by function. You see one problem being solved pretty quickly. And you can think about how that works. So this is an ESRI tutorial, and it's basically site suitability and data transformation. If you search for that for ArcGIS Pro, if you search for that, you can find this data. The criteria they give us is for eagle nesting habitat, and specifically they're looking for data in places far from developed areas, areas that are not too densely or sparsely covered by forest, areas that are close to lakes and are located on northeast facing slopes. So the close to lakes are interesting. You want to be between on the lake and within 2 miles of the lake is what it's specifying. And they give us some of the data sets, and we can talk at some point in time if you want about where you get this data and how the data is derived. But again, for the sakes of this video, I'm going to take some steps here and try to highlight what you really want, and perhaps pause the video here and there and jump forward so you can see this in a timely manner. So the first tool is aspect, and given a digital elevation model we can derive aspect using, that's right, the aspect tool. And you guys have done that. The output is azimuth from 0 to 360 degrees, or a -1 value if it's on a flat surface. And if we think of this as a hill, this oval, and these ellipses, a normal ray coming off of the surface that then gets pointed downward towards the horizon gives us an azimuth. And the range of these values are our azimuth. You can see north is between 0 and 22.5, as well as from 337.5 to 360. That's this cell right here on this hill. And then we have some other values that are derived here. What we want is northeast facing slopes, so slopes that are 22.5 to 67.5. And that doesn't mean that north doesn't work or that east doesn't work. It's just northeast is better. And so we're going to assign values that are shown here for the different facing slopes. Now, I'm going to caveat all of this. My expertise is more in geospatial information science. I am by no means, and I don't even begin to suggest that I am good at habitat suitability for eagles or any other sort of bird. But I can assist someone who's interested in this because I have GIS skills, and that's what we're trying to get at here, is get you armed with some of the basic skills, know what you can do. You can always reach out to somebody who's an expert to help you with some of this stuff, or if it's somewhat simple, you can do it yourself. So for the environmental scientist, you're learning the capabilities. Hopefully you learn some basic skills. You can do some basic things yourself, but you can always go find somebody who's great at GIS to do this stuff. So the expert gives me this table, and I'm going to transform values that have a range of 22.5 to 67.5, and I'm going to give those values a 10. Those values that are north-facing aspects are going to get a value of 9, and those that have east values are going to get a value of 7. And there's other ranges here that gives us values of 7, 6, etc. So I wanted to show you that breakdown. And we'll jump straight to ArcGIS Pro and show you how this is done. Let's look at the data. First, what I'm looking at here is an elevation data set. This can be provided a lot of places. The U.S. Geological Survey, New York State Clearinghouse has elevation data for New York, and the list goes on. If I zoom out on the base map, you can see that we're dealing with California. I'm going to turn that off just so that we can move a little faster. Other data that we have is a land cover data set, and they tell us exactly what the different land cover values are. This is actually a very common product. If you have Landsat thematic mapper data, which is free for download, in fact you can search that on YouTube and you can watch somebody actually download Landsat thematic mapper and then do a classified supervision or an unclassified supervision of each pixel, and the computer does this for you rapidly, and the output looks a lot like this. And you would do this in EV377 or EV477. Both of the classes do classifications of land cover. It's a very common requested product. We have canopy cover. You can get this a few different ways, and again it gets into some remote sensing, but this is a scale of 0 to 87% canopy cover, provided to you, again, primarily through remote sensing means. And then we have our lakes data sets here. So some of what we need to do is think about, does the data that's provided give us what we need? And we're not going to immediately just reclassify elevation if what we want is aspect. We've got to run the tool aspect. So if we search for aspect, oh, that's catalog. Probably ought to go into analysis, tools, and search for aspect. We're going to enter our elevation data. Our output can be aspects, fine, and let's just run this and see what happens. It's looking promising, and our aspect populates. So this gives us exactly what we saw before and what we were hoping for. I'm going to remove elevation. I've got aspect now. I really don't need my elevation data. If you wanted to make a base layer map or have hill shading and do some other things to make a pretty inset map or something else, you could keep it. But I'm just trying to get transform data to do some calculations. So I'm okay with this. But I haven't transformed my data to that table that we had here where my values look like this. So to do that, we're going to use the tool that I demoed in the previous lesson. Hopefully you saw the tool Reclassify, where we at least talked about in class. We're going to enter the tool aspect. Value is what we're going to use, and as we put our cursor over classify, the tooltip comes up that says this is going to automatically calculate equal interval values. Well, it's equal interval, or we can then manually go in and change the values. So when we use the classify tool to break down our values here or here, when we see our numbers, we could use those numbers to manually enter them into our reclassify values. And that's what I'm going to do here. From -1 to 0 is flat, and it gets a value of 1. From 0 to 22.5, I get a value of, we said 9 for north. Now what's important is we use the same, we end at a number and we start at that same number, so something doesn't get left out. This is just what ArcGIS Pro wants. I know it may seem confusing to do that, but trust me, that's what we want to do. So we got 67.5 and ending at, so that ended at 67.5, so we'll start there. 67.5 to 112.5 gives me east. So we said from 0 to 1 to 22.5 is north. It gets a value of 10. Northeast, or 9. Northeast gets a value of 10. East gets a value of 9, and the list goes on. And I'm going to recode these numbers. I'm going to run this tool, and I'm going to add it. But for the sake of time here, I'm going to pause this demo, and I'll just come back in after I've got my reclassified data set entered. Okay, just so you guys see it, I've got my data entered here. I'm actually taking a shortcut. I could add another row here and have a value of 7 set up for a portion of east as well. And I'm just going to go ahead and skip that, leave it a little bit more simplistic, and run this. So the values of 10 are my northeast. My values of 9 are both north and east. And so this is what we end up with as our final output. So I can now remove my aspect information. I have transformed data that's a reclassified aspect layer. So one of my 4 criterias are set up, and that's my aspect piece. We go in here and we say located on northeast facing aspects. I've got weights of 1 through 10 assigned there. Working backwards, I could work on lakes. I want to be less than 2 miles away from major lake polygons. So if we go into ArcGIS Pro, and let's go ahead and turn off this guy. We've got lakes here, and we have a lakes layer. If I turn everything off, we have a lakes layer. Well, the first thing we need to do is find a way to get distance from lakes. And there's a pretty basic tool out there called, let's just see what happens if I type in distance. We've got cost distance, path distance, flow distance. Down here is a tool called Euclidean distance, and it calculates for each cell the Euclidean distance to the closest source cell. This is what we want. So from lakes, I'm going to have a Euclidean distance to lakes. I don't have a barrier. Output cell sign's fine. All of this stuff is good. And I'm just going to run this. Thinking about the output file name always, I'll know what that term is. And we get a new raster. Distance from lakes, you know, they provided us, each of these cells, there's a cell value for each of these. If you're 1 meter from the lake, that raster cell is 1. If you're 10 meters from the lake, that cell value is 10, if depending on the cell size. I think the cell size for these are 30. So if we're 60 or 65 meters away, we're going to get a value of 65 for that 30 by 30 meter cell. We can see what these values are. This is in UTM coordinate system, so these are meters. So 3,440 meters is this dark green area. And what we want, if you remember their criteria, we want to reclassify our values to be within 2 miles of the lakes, and really set a scale of from 10 to 1 being on the lake edge to 1 being 2 miles away from the lake edge. So we've got our distance. In fact, because we have our distance, I'm going to continue to do what I did before. I'm just going to go ahead and remove my data, which is lake. And I want to now reclassify values and get some sort of a value of 10 to 1 out here, and the rest of it will just be a value of 1. I can set a buffer and clip everything to 2 miles of my lake at the end if I want. If I say I don't want anything outside of 2 miles from my lake. But for the time being, I'm just going to go ahead and show you a different tool that's going to get a hold of what we want. And the tool's Rescale by function. We talked a little bit about it. It's on the last slide of our last lesson. So if I use Euclidean distance of lake 1, rescale, and I'm going to call this rescale lake, just so that I know that that's what it is. And the transformation function is what's important. When you're dealing with these tools and you move your cursor around, you can find these little I buttons and you can get your tooltip. And it'll tell you what your attribute domain options are to select. And we can read through these. What we want is we want to create a high value from what's close to the lake. My initial thought is the term near. Now, I know that that's not right. Near is, you use this when the input values are very close to the midpoint. Well, that's not what we want. What we really want is small numbers. We want the numbers closest to the lake. So what we want is small. And again, you can see here small, used to indicate the smaller values from the input raster have higher preference. So we're going to come over here and we're pick the term small. Midpoint in this case is 1609 because we're only going 2 miles. We're going to leave the rest okay. Upper threshold is 1218 because that's 2 miles. A value above the threshold, we're going to assign a value of 1. And then we're going to have a rescale value of 1 to 10. And we're going to run this. We're going to see what happens. 10 is close to lakes. 1 is 2 miles or more away from lakes. And I could zoom in and I could use the measure tool, and you would see that that gives us what we wanted. Let's see what happens if I do the same thing, but I change the name to Rescale 2, and I'm just going to put TST. And let's see what would have happened if I used the term near instead. Wonder why it's giving me this guy. Oh, we got to actually use Euclidean distance lake. No kidding. We're going to call this lake 2 test. That's what I meant to do. We're going to use near. Midpoint we said was 1,600 meters. In this case, spread, we'll use this value. Lower threshold is 0, upper threshold is 3,218. Value above we said would be 1 to 10. Now remember what we said before. We want values from 1 to 10 as we go away from the lake. But as we sit here and we look at this, we have this really weird thing right here. I wonder where that is. So if we go in and we use map and we use our measure tool, and we come out to the edge and we measure outward to this area, to the closest area on this guy, we're at about 1,609 meters. So we're 1 mile away from the lake. The near term, when we come over here and we look at the information here, is it's assigning a value where we want to be close to the lake, or we want to be close to a midpoint in the range of values. And the range of values I actually gave the midpoint of 1,609. So that value is really high if you're at 1 mile away from a lake. The reason why I'm showing you this is you've got to check your work. If you use the wrong method, it's obvious when you've got the wrong data. So the right data is this one here. I'm going to remove my test layer that I had, and everything looks right. So that was just a kind of for the sake of argument or futility. After you run a tool, and if you're reading the instructions and you misclick something, still look at the information and ask yourself, is this what I'm trying to get? And in this case, I sometimes think the term near when what I really want is the term small, and that's why I was showing you that. Okay, so I've got a rescaled value for the lakes. I can get rid of my distance from lakes. I already got rid of my lake layer. Coming over here, another thing we can do is canopy coverage. So we've got percent canopy covered. We want canopy that's at 45%. So we're going to rescale our data so that the values of 45 get high values and the values away from 45 as they go away from 45. So from 45 up to 87 as it goes to 50 and down to 40. 50 and 40 will have the same value, but it's going down from 10. So we're going to do that now. What tool do we think we're going to use for that? Well, we're going to use rescale by function again. So the input raster is canopy cover. The output raster can be rescale CC, canopy coverage. We're going to use the term, in this case, if you remember the term I just gave you, near, and that near midpoint is 45. The spread, let's see what it told us. I think it's probably 0.001. It is. Midpoint is 45. Lower threshold is 0. Upper threshold was 87. Value above threshold, we'll go ahead and give it a value of 1. Scale from 1 to 10, and let's run this. Okay, so we have our rescaled canopy coverage values. areas where there was no canopy cover, we know we're going to have a value of 1. So all that area that was previously white is going to have a value of red, or a value of 1, and that kind of looks right. And then the rest is going to be hard to tell because of the way the scaling works. But this looks about right to me based on what I've seen. So I'm just going to go ahead and roll with that. I can remove my canopy coverage. I've got 3 rescaled sets of values. I've got my canopy coverage on a scale of 1 to 10, my lakes, distance from lakes on a scale of 1 to 10, priorities close within 2 miles, and my reclassified slope values or aspects. So the final thing is to be a certain distance. I want to be far away from developed areas. And this becomes a little bit tricky because what I really want is to get a hold of just developed areas, use the Euclidean distance tool again. After I use the Euclidean distance tool from just developed areas, I can do my one of my rescale by functions piece. So this is a little bit more tricky because I've got a raster here that's got some cells. I need to get a hold of just those cells and then use the Euclidean distance tool from that. There's a couple ways we could do this. We could convert this to like vector data and try to get, and then do a selection of just the developed tool or developed areas and do Euclidean distance that way. We could do a reclassify and just get a hold of developed areas and turn everything else off or down to 0 and then do a distance from just the developed areas or set it to no data. So a few different ways we can do this. I'm going to go ahead and do a shortcut and get my developed areas and then I'll come back to you and I'll explain what I did. Okay, so I've got my developed areas. What I actually did was I used Raster Calculator and I just said assign a value for these different developed area class numbers. I know what the values were for these numbers. If it equaled a certain number, assign a value of 1. And anything else I left alone. So the only thing I got a hold of was the developed area pixels, and just a couple of them. The low intensity or the open space developed areas I didn't use. But when we turn on the land cover, you can see that my red areas line up with the current red areas from the previous raster. So that's beyond the scope of something that we've seen so far, so I didn't want to show you or walk the dog too far on that. So again, the next tool to get a hold of distance from these guys is to use the toolbox Euclidean distance. Input raster is going to be my developed areas, no barrier, and we run it. Once this runs, we're going to check our work. We can put our developed areas on top of this, and we can see close distances from red. Where there's no red, we're farther away. Euclidean distance worked pretty well on that, so we know that's right. We can get rid of our developed areas. And now what we want to do is a rescale by function these guys, where the farther away we are, the better the number, the higher the number. So we'll go in, we're going to use our rescale by function again. Input raster is Euclidean distance, or Euclidean distance dev1. Transformation function here, we want large values. We're going to keep everything the way it is because it automatically knows our numbers, and we're just going to run it. And if we just turn on the rescale by number, 10 being our far away numbers, paying attention to our green areas, red being close to developed areas, as we turn this on and off, this corresponds with what makes sense from this distance raster. So that's good. Our rescale by function worked. Again, I can remove this. I now have, and I can remove land cover, I now have 4 rescaled layers, all valued between 1 and 10. As we zoom into certain pixels, we can go through, and I can just say, all right, these pixels in my current screen for rescaled distance is probably going to be a value of 1. turn these other guys on, and I'll go in order. This one has a wide range. We're going to have pixels here that have a range between 1 and 10. This is rescaled canopy coverage. Rescaled distance from lake. They're all going to get on a kind of a range of maybe 9 to 8 maybe, or 9 to 7 maybe. Distance from lakes. And then our aspects, we're going to have a wide range of numbers as well. So within a few miles of a lake, or within the 2 miles of a lake, we're going to have a wide range of different numbers. Now again, we could say we don't want anything within 2 miles of a lake, and we could do a buffer and use the tool clip and just say, I don't want to use or look at anything else, anything that's not within 2 miles. But just to show you the tool Raster Calculator and what it can do with all our information, let's use Raster Calculator. And this is really simple. It doesn't necessarily look simple, but it is really simple. I've got my different rasters here. The fact that I've got reclass, rescale, 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 I know it's these 4 because I removed everything else. That's why I was removing stuff as I was working. I'm just going to add these numbers. They're going to be numbers from 1 to 10. I'm going to add them all up, and I know that 40 is going to be the best and the lowest number is going to be the worst. So if I go this guy, double click, double click, double click, double click. I'm just double clicking these numbers. I've got a rescale Euclidean distance. I'm just going to put an underscore add, which is I'm just adding them. I'm going to run. And it says a parameter's missing. Of course it is. Oh, I'm missing I don't need this guy. Again, it's great to troubleshoot and just kind of check your work and make sure things work. We're all human. So I have values ranging from 4 to 30. 4 meaning a whole bunch of values that had my lowest number possible. And as I zoom out, you can kind of see what's going on here. I could turn on lakes, I could add my layers back, and you'd see where our lakes are. But white being good, black being bad, you can see the areas close to lakes are getting pretty high scores, and a couple of the areas really far away from developed areas were getting pretty decent scores. Now again, we could do a buffer from our lakes, clip everything to just the 2 miles within lakes if we wanted, and we could look at the ranges inside the lakes if we wanted to exclude anything 2 miles out. Another thing we could do is we could create a new raster and assign weights and just say, multiply the distance from the lakes. It's 2 times more important to be within a certain distance of the lake, or the tree coverage is more important, and we could just come inside our raster here and start multiplying these values, put in parentheses, and just say, 50% of what's important here is this. And I could just type in, 0.5 times, like put in parentheses, right, 0.5 times this guy, right, and then over here, 0.1 times this guy, put in my parentheses, right. This is actually coding, but it's just simple math. And we can say 0.2 times this guy, put in my parentheses. We can put some spaces in here and make sure this stuff's right. And so we got 50%, 60%, 70, 80%, so this guy would need to be the same thing, put in our parentheses. So this sums up to 100%. When we think about what this is going to look like, I'm going to rename it. We know that 50% of a value of 1 to 10, 20% of a value of 1 to 10, 20% of a value to 1%, or 1 to 10, and then 1% of a value of 1 to 10, it's going to get ourselves onto a very interesting scale. We know what that number should be. See what this is telling us. So I don't have, this should be fixed. So I know what the number range I think it should be, and I think it should be on a value of 1 to 10. And it looks like that's probably right when I had this scaled at about 30, which the max could be was 40. It makes sense that I'm not going to see a value of 1 to 10. And this is how we can assign weights to these different rescaled functions if we wanted. And you can see these values on a scale of 1 to 10, these values on a scale of 1 to 30. In general, they look a lot alike, but you can see how adding percentages change. So hopefully this gives you a little bit of an understanding of a few things that we can do. The rescale by function, reclassifying data, Euclidean distances, and the raster calculator in particular, and then how we can use that to then assign values and kind of prioritize where we think habitats would be in this case. Of course, this could be used for a lot of other things, but hopefully this helps you understand some of the tools that we've been using over the last few weeks. Have a good day, guys.